Welcome to the DIY Honda Garage channel. The DTC P0506 indicates an issue with the idle control system in the Honda Civic models 2011 through 2015. This code specifically signifies that the RPM is lower than expected during idle conditions. The primary components affected include the throttle body, which regulates airflow into the engine to maintain proper idle speeds, and the engine control module, ECM, which manages engine performance. These components are integral for ensuring a smooth running engine, particularly at idle. The throttle body is located between the air intake duct and the intake manifold. The ECM, on the other hand, is typically located near the engine compartment, often near the battery. When this DTC is triggered, it's crucial to perform a systematic diagnosis to rectify the underlying problem. DTC P0506 pertains to the idle control system, suggesting that the RPM during idling is lower than the desired threshold. The throttle body plays a critical role in this scenario, as it controls the amount of air entering the engine based on the driver's demand and the ECM's inputs. The throttle body is situated directly after the air intake duct and before the intake manifold, making it a vital component in the air-fuel mixture process. The engine control module, or ECM, oversees the throttle body operation and ensures that the idle speed remains stable, which is essential for the vehicle's performance and emissions control. A malfunctioning throttle body or incorrect signals to the ECM can lead to an irregular idle speed, triggering this DTC. Therefore, understanding the roles and locations of these components is key to diagnosing the issue effectively. There are several possible causes for the DTC P0506. One common reason is a dirty throttle body, which can accumulate carbon deposits and dirt, impacting its ability to open and close correctly. These deposits can restrict airflow, resulting in lower engine RPMs. In some instances, the throttle body might be physically damaged, which would necessitate its replacement as it cannot function as intended. Additionally, issues with various sensors can also lead to this DTC. For example, the engine coolant temperature, ECT sensor, and the intake air temperature, IAT sensor, both provide critical data to the ECM. If these sensors are sending incorrect data, it could mislead the ECM and cause it to mismanage idle RPM levels. Therefore, it's important to carefully examine these components during the troubleshooting process. When the DTC P0506 is present, drivers may experience several symptoms. One noticeable symptom is a rough engine idle, which can manifest as vibrations or irregular engine speed when the vehicle is stationary. The RPM may drop lower than the expected levels, leading to a feeling of instability in the vehicle's operation. This could potentially result in stalling under specific conditions. Additionally, the vehicle's check engine light will typically illuminate, alerting the driver to a problem that needs diagnostic attention. These symptoms emphasize the significance of addressing the DTC promptly to prevent further complications and to ensure the smooth running of the vehicle. The first step in troubleshooting DTC P0506 involves several key procedures. Begin by turning the ignition switch to the on-to position, which activates the electrical systems without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear any stored DTCs, ensuring a fresh start for the diagnosis. After clearing the codes, start the engine and hold the engine speed at 3,000 RPM without any load, meaning that the vehicle should be in neutral. Maintain this speed until the radiator fan activates, then allow the engine to idle. This process generates important data that will be monitored in the next steps to check various parameters that can affect idle speed. While performing this initial step, always ensure to record all freeze data and snapshots for future reference, as it aids in understanding the circumstances leading to the DTC. The second troubleshooting step focuses on visual inspection of the throttle body. To begin, remove the intake air duct from the throttle body, allowing clear access for evaluation. Once the duct is removed, closely examine the throttle bore for any signs of dirt, carbon buildup, or physical damage. Carbon deposits can significantly affect throttle response and idle performance, potentially triggering the DTC P0506. If dirt or carbon is present, the cleaning of the throttle body is essential. Make sure to also inspect the air cleaner element for any damage or blockages that might influence airflow. However, if the throttle bore exhibits physical damage, replacement of the throttle body may be necessary. After completing this inspection, it is crucial to move on to the next steps to verify if this has resolved the issue. In Step 3, a similar visual inspection of the throttle body is conducted again. This redundancy ensures that no issues are overlooked during the diagnosis. As previously mentioned, begin by removing the intake air duct to gain proper visibility of the throttle body. Check meticulously for any dirt, carbon buildup, or signs of damage impacting the throttle bore. If dirt or carbon is found, cleaning is imperative to restore optimal airflow through the throttle body. Alongside this, reevaluate the air cleaner element for damages. If there's no visible damage to the throttle body, it's deemed acceptable. With the throttle body confirmed to be in good condition, you can proceed to the next step, checking the idle control system to gather more insights into the issue at hand. In the fourth troubleshooting step, an idle control system check is performed to gather more specific data regarding the idle operation. Start by turning the ignition switch to the on/to position again. Clear any DTCs using the HDS as done previously. After clearing, start the engine and maintain a speed of 3,000 RPM without load until the radiator fan turns on. Then allow the engine to idle naturally. At this point, you should use the HDS to check the data list for specific conditions. Ensure the ECT sensor is reporting above 158 degrees Fahrenheit, 70 degrees Celsius. The intake air temperature is above 32 degrees Fahrenheit, 0 degrees Celsius. Vehicle speed is 0 miles per hour, 0 kilometers per hour. The short-term fuel trim value is between 0.69 and 1.47, and the fuel shutoff status is closed. These conditions are critical indicators that will help in determining if the system functions satisfactorily or if further investigation is needed based on the OBD status. Final repair verification is essential to determine whether the previous troubleshooting steps were successful. Begin by turning the ignition switch to the lock 0 position and reconnecting all electrical connectors that may have been disturbed during the troubleshooting process. Next, turn the ignition back to the on/to position and use the HDS to reset the engine control module, ECM. This reset helps clear any residual fault codes and allows the ECM to relearn idle characteristics based on the vehicle's current state. After resetting, perform the ECM idle learn procedure, which involves starting the engine and maintaining it at 3,000 RPM without load until the radiator fan activates before allowing it to idle. Finally, check for specific conditions using HDS again to verify ECT sensor readings, IAT sensor readings, vehicle speed, and fuel trim values. Conclusively, monitor the OBD status to see if it indicates passed, which would confirm that troubleshooting is complete. Preventive maintenance can significantly reduce the likelihood of encountering DTC P0506 in the future. One effective method is to perform regular cleaning of the throttle body. Doing so prevents the buildup of dirt and carbon, ensuring it operates optimally. Concurrently, monitoring the performance of critical sensors, including the ECT and IAT, can help catch issues before they develop into significant problems. Regularly inspecting the air cleaner element also helps ensure that air intake isn't restricted, allowing the engine to function efficiently. Additionally, keeping an eye on fuel trims can provide insight into overall engine performance. With these preventive measures in place, the vehicle's idle performance can be maintained at optimal levels, thus mitigating the risk of trigger codes like P0506. In conclusion, addressing DTC P0506 involves a systematic approach to troubleshooting and repair. Thoroughly understanding the roles of key components, such as the throttle body and ECM, is crucial for effective diagnosis. The steps provided guide technicians through both preliminary checks and necessary repairs, ensuring careful assessment of the idle control system. Regular maintenance practices can prevent the formation of dirt and deposits that may trigger similar DTCs in the future. Being proactive with diagnostics and timely interventions can help maintain the vehicle's efficiency and longevity. Ultimately, knowledge and adherence to the outlined steps serve as a roadmap to resolving idle control issues and enhancing overall vehicle performance. Please like and subscribe to the channel. See you next time.